Today we're going to look at inequalities, and by the end of this lesson you'll be able to graph inequalities on a number line and solve inequalities. You've heard of inequalities before, you just didn't know that they were called inequalities. Inequalities essentially show a range of values. So that's where we use the four inequality signs are the greater than sign, greater than or equal to, less than or equal to. So remember the greater than or equal to, less than or equal to. So there are four inequality signs, and they allow us to show a range of values. So if we're looking at the first example here, x is greater than a. What we've got, if we have a look at how that's being graphed on our number line here, we've got our value x. We've shown that all of our value, whatever x is going to be, it's going to be greater than some point a on our number line. You can notice that there is a circle that's not filled in. Okay, so there's it's a dot that's not been filled in, and then we're drawing an arrow showing that it's all of the values that are greater than or bigger than that to the right of it on the number line. The empty circle represents that x might be greater than a, but it can't be a. So think about, is 5 greater than 5? No, it's not. 5 is equal to 5. Okay, so that's what we're kind of representing with our hollow circle, is saying that it is definitely not equal to a, but it is going to be bigger than a. If we look at the next example down here, that x is greater than or equal to a, then we can see that the dot is filled in, which symbolizes, yeah, it could be a, but it could be bigger than a as well. Okay, so our values for x are greater than or equal to a. Similarly, we would, to graph less than, we'd use the same not filled in circle and show the arrow moving to the left here. So the non-filled in circle and arrow moving to the left, showing that we're looking at all values less than a, but not equal to a. If we're looking at less than or equal to a, then we fill in the dot and say, yep, could be a, or it could be less than a. We can also represent ranges of values in this way. So our last example here that we're looking at, the way we would read this is that x is in between a and b, but not equal to a. Okay, so b, it could be b, but it's not going to be a. It's somewhere in between those values, and you can see that's represented here because there's no it's less than or equal to. That means our circle is not filled in, and because it is greater than or less than or equal to b, then that is going to be a filled in circle. So our value for x is somewhere in the middle here, in between a and b. So x is less than, a is less than x, and x is less than or equal to b. That's what we've got there and represented in our graph. So let's have a look at some examples to start with. We're being asked to write the following as an inequality. So if we have a look at a here, we've got a non-filled in circle, so we know that it's not equal to at all. And it's our value for x, so it's x that we're looking at here, that's shown on the graph there, x. It's going to be greater than because it's moving to the right, but it's not greater than or equal to, and the value is 2 on our graph. So our graph is showing that x is greater than 2. For our second one here, our value is x, and if we have a look at the lower end, x is going to be greater than -3, greater than or equal to -3. So if we have a look at drawing and representing this, we'd have greater than or equal to -3, and then we can have a look that x is going to be less than but not equal to 0. So our annotation here, our notation shows that x is in between -3 or 0, but not equal to 0. So we can see from our graph that the -3, it's between -3 and 0 here. So we've got our lower and upper bound. We've got here that because the circle is filled in, here on the -3, that it is less than or equal to the sign that we're using, and because the circle is not filled in here, then we've got not less than or equal to, just less than, and we can see that our x is in the middle here of both of those values. When we're solving inequalities, solving linear inequalities, it's exactly the same as solving a linear equation. There are only two exceptions, two little things that we need to think about and worry about, and we can see the reason why we do this. The first one is if we reverse the inequality sign, we'll reverse the inequality sign, so it'll go from less than to greater than, or greater than to less than, if we multiply or divide by a negative number. So let's have a look at why we do this. So the reason that we do this is because if I've got -5 is less than -3, that's a true statement. -5 here is here on the number line, and here is -3. I can see -5 is less than -3 on the number line. Okay. If I multiply both sides by -1, that then becomes 5 and 3. The -5 becomes 5, and the negative, so multiplying both sides here by multiplying or dividing by -1. Okay, multiplying or dividing by -1, you'll get the -5 becomes 5, and the -3 becomes 3. 5 is less than 3 doesn't make sense. You can have a look at 5 and 3 and compare them on the number line here. 5 and 3, 5 is greater than 3. Okay, so when we multiply by a negative number, multiplying by a negative essentially switches the side of the number line that the values are talking about and discussing about. Rather than being on one side of the zero, they're on the opposite side. And so in order to do that, we're mirroring what's happening on the number line. So in order to do that, we need to mirror our inequality sign as well. We need to mirror, turn it from a less than to a greater than, or a greater than to a less than. Also, if we switch the sides, we need to do the same thing. So if I've got here 2 is greater than x, so if I have a look at our value 2 here on the number line, 2 is greater than x. So that means, or greater than or equal to x, sorry. So that means that x is somewhere down here. Okay, 2 is greater than or equal to x. Then if we're switching the sides, we're switching our perspective. Now we're looking at where is x in relation to 2. So x itself is less than or equal to 2. So in relation to the 2, we are now less than that value. So essentially what it does, when we switch the inequality, or when we switch sides rather, we're switching our frame of reference from saying 2 is less than x to 2 is greater than or equal to x, so 2 is the bigger number, x is less than or equal to 2, we're saying x is the smaller number. So we're just shifting our perspective on which is essentially the subject of that inequality, so which is the one that we're talking about. So that's why we need to switch that inequality sign. So they're the only two exceptions to all of the normal rules that we have for solving inequalities. So let's have a look at two examples and graph them on a number line to be able to see how that will work in practice. So if we've got this inequality here, I've got 4 minus x over 3. That is less than or equal to 6. So having a look here, we need to try and simplify as much as possible. Let's subtract both sides by 4, or subtract 4 from both sides rather. I'll get negative x over 3 is less than or equal to 2. So what I'm going to do now is I'm going to multiply both sides by -3. If I multiply both sides by -3, that will make this side, the left-hand side, become positive x, just x, and we can see how that affects the other side. So if I multiply both sides by -3, I'm multiplying by a negative. Because I'm multiplying by a negative, I need to switch the direction of the sign. So because I'm multiplying by a negative, multiplying by -3 on the other side, I will get -6. there, -6. So we're left with, and solving this inequality, x is greater than or equal to -6. So if I have a look at -6 on the number line, I can say, all right, greater than or equal to, that means a filled in dot at -6, and we're looking at greater than or equal to, so then we can draw our arrow going up here, and this is our value for x. So x is greater than or equal to -6. Having a look at our next example, we've got here 3x plus 2 is greater than 6x minus 4. So having a look at subtracting from both sides, all we need to do is simplify. Let's take 3x from both sides. I'll get 2 is greater than 3x minus 4. Let's add 4 to both sides. Adding 4 to both sides, I'm going to get 6 is greater than 3x. I'm going to divide both sides by 3 and get 2 is greater than x. And because I want to graph x, I probably want to make sure that x is the subject, so I need to switch the sides. And because I'm switching the sides, I need to switch the inequality. X is less than 2. So let's have a look at graphing that now on our number line. Because it's less than and not less than or equal to, it needs to be a hollow dot, so it's just a little tiny circle, and we're looking at x is less than 2. So I'm going to graph all the ones down here and say that's what we're looking at for x.